Okay, now I'm starting material that won't be assessed until second semester, but we need to understand the stuff because it is coming at you. Okay, this standard will be the first standard one of the second semester. It's titled Systems of Equations. That means there's always going to be two equations and there's two variables. And the variables are almost always x and y. Okay, so here, I want to know if this works for both equations, okay? So what I'm going to do is replace x with -3 and y with 1 and put equals -2. So -3 and 1. Now, here, again, I'm going to replace the x and y with parentheses. X is -3 and y is 1. It'll go quicker if you just kind of calculate it. -3 plus 1, that's going to be -2. So that's true, so put a check. Now let's see if the other one works. So -3 plus 5 and then 1. For some of you that want to do it on the calculator, that's 2. So 2 equals 2, and that's yes. So it's yes for both. So then the answer is yes. It's got to be yes for both. It can't be one and not the other. It's got to work for both. Okay, so let's look at the first one. Let's just ignore the second one for now. So 6 parentheses plus 5 parentheses equals -7. Okay. So we're going to put -2 and we're going to put 1. Now let's write the other one. So parentheses, parentheses. So it's going to be parentheses minus 2 parentheses equals 0. So we're going to put -2 and then we're going to put 1. Okay, so I've got 6 times -2 plus 5 times 1, -7. Okay, so that's -7. That's yes, that works. But does it work for the other one? Oh, sorry, I mispunched that in. -2 times 1. Well, that's a problem. That's not true, so that's no. Okay, so no. It's got to work for both of them. Okay, and guess what? There's only one XY combination that's going to work for both of them. This happened to be it. This was not it. I don't know what it is, but I know it ain't the -2, 1. That's not a combination that'll work. Forget this page. I don't know why. Now, here's the first way to find the one combination that makes them both yes. Okay, that's what you're trying to do, and that's graphing. So here's what I want you to do. I want you to label that equation number 1 and that equation number 2. So just focus on number 1 first. Don't even worry about 2, just number 1. Okay, here's the equals. The y is not by itself, so I will put 0 in for x and 0 in for y. So I copy it down twice. Remember, I'm doing equation 1 first. I'm not even looking here, okay? I'm not even pissing with that one, okay? Pardon my language. So x is 0, get that out of there. And y is just equal to -8. You don't need to divide because y doesn't really, you can put a 1 there, but it'd just be the same. Y is 0. I have 2 multiplied by x is -8, so I divide by 2. And -8 divided by 2 is -4. Okay, so 0, -8 means I go down 8. So 1, 2, 3, 4, 5, 6, 7, 8, all the way at the bottom. And you want to go by 1s here. Don't go by 2s today. -4, 0, that means I go left 4. So 1, 2, 3, 4. Now you need to take a ruler or something to draw the straight line because this line's got to be straight as can be. Okay? Both lines have to be accurate. Now, do not draw a little wussy line, okay? You can put arrows, it doesn't really matter, okay? Now I'm going to do equation, that was equation number 1. Now I take on equation number 2 and get that down. So, is the y by itself in number 2? No, it's not. Okay, so I've got to use the 0 for x, 0 for y method again. So I copy that down twice. 2x minus 2y equals 8. 2x minus 2y equals 8. Okay, we're not doing anything in that graph. Okay, the only reason that's there is because that's a graph paper I normally have. So x is 0, so we get rid of that. Y is 0, we get rid of that. Now divide by negative 2. It's going to be negative 4. Divide by 2, and that's 4. Okay, so I'm going to go down 4, and I'm going to go right 4. So 1, 2, 3, 4. And then 4, 0. So 1, 2, 3, 4. Okay, now connect those points. Make sure the line kind of goes as far as it can so it covers the whole graph. Okay, my question is, did these lines cross? Mark the point where they cross. Okay. Now, I want you to go like this, x, y, and tell where those points intersect. So, sideways it looks like you're at negative 1. Okay, so I'm sideways negative 1, about. Okay, you got to kind of estimate. You're about at negative 1. So x is negative 1. Now let's look at y. How many squares down am I? 1, 2, 3, 4, 5. So about 5, but it's down, so it's negative 5. Well, let me repeat that again. Start in the middle. You're left 1, and then I'm right above the point, so negative 1, because left is negative. And then down 1, 2, 3, 4, 5, about 5, closer to 5 than 6. Okay, so negative 5. Just get a good guesstimation of where they cross. Okay. Okay, my next problem. This is number 1. This is 2. Let's just focus on 1 first. Here are the y's by itself. Okay. So I can use, it's in slope-intercept form. So I can use the 0, 1, 2. Just plug that in for x. This would actually have a negative 1. Okay. If you prefer MB, your slope would be negative 1 over 1, and the y-intercept would be 4. Okay, so if I plug 0 in, I'm going to take negative 1 times 0. And again, I'll put a parenthesis so you can see I'm plugging that in. So negative 1 times 0 plus 4 is going to be 4. Negative 1 times 1 plus 4 is going to be 3. And then our next one is going to be 2. Okay, so 0, 4. 1, 2, 3, 4. And then 1, 3. I go right 1, 1, 2, 3. And then 2, 2. So right 2, up 2. Okay. Now take your ruler because you got to make it straight today. You can't just make it wobbly, kind of like I've let you in the past. Okay, cross 1 out. We're done with that. Now look at 2. Is the y by itself? Y equals 2 times x minus 8? Yeah, it is. Okay. So it's in slope-intercept form. So again, I can just input 0, 1, 2 for x. Again, no multiples because there's no fraction. You could also use m and b. The slope would be 2 over 1, and the y-intercept would be negative 8. Okay, so we're going to put those in. 2 times 0 minus 8 is negative 8. 2 times 1 minus 8 is negative 6. And there is a pattern that's negative 4. So 0, negative 8. I go down 1, 2, 3, 4, 5, 6, 7, 8. 1, negative 6. I go right 1, down 1, 2, 3, 4, 5, 6. 2, negative 4. I go right 2, down 1, 2, 3, 4. Okay. Now, again, please draw your line straight as can be. Okay, do the lines cross. You need to mark the point where they cross and then name the point. It's an XY coordinate, okay? XY. So on the X, I got to get to here. So I'm 1, 2, 3, 4. So if X is 4, positive because I moved to the right. So I just put a 4 there, okay? And then I'm not really up or down at all. I'm pretty much right on the axis. So since I'm not up or down at all from the middle, the Y is 0. Okay, so 4, 0 is the point, is the one XY combo that makes them both true. Okay, next one. Same idea. Okay, this is 1, this is 2. Okay, so let's look at number 1. Okay. I'll do number 2 here. Number 1, is the Y by itself? Yes, it is. So it's in slope-intercept form. So I can just input 0, 1, and 2. If you like the MB, the slope-intercept, it would be negative 3 over 1 is your slope, and then 2 for your Y-intercept. So you go to 2, then down 3, right 1, down 3, right 1. But most of you just prefer plugging the numbers in for X. So negative 3 times 0 plus 2 is 2. Duh. I don't know why I'm using a calculator for that. Negative 3 times 1 plus 2 is negative 1. And then negative 3 and then 2 plus 2 is going to be negative 4. Okay, so just graph the points. So 0, 2. 1, negative 1. So I go right 1, down 1. 2, negative 4, I go 2, down 1, 2, 3, 4. Okay, so make your root, take a ruler or straight edge and make that line as straight as you possibly can. Okay, so that's all the points that make that equation true. Now, but it's got to have an intersection point. Okay, now the other one again, the Y is by itself, so again it's in slope-intercept form, so I can use, most of you prefer to use 0, 1, 2 when it's set up like that. So 2 and then 0 minus 3 is negative 3. 2 and then 1 minus 3 is negative 1. Okay, 2 and then 2 minus 3 is going to be 1. Okay, so 0, negative 3. 0, negative 3, 1, 2, 3. 1, negative 1, so I go 1. And there's already a point there, so all right. So 2, 1, so right 2, up 1. So I'm going through these points. If there's already a point there, then you pretty much have your intersection point because you know that's the point where they're going to cross. Okay, and then I've already circled the point where they cross. Now, put your pencil there. You are 1 to the right, so positive 1, and then you're down 1, so negative 1. 1, negative 1 is the point. If I put negative 1 in for Y, 1 in for X, negative 1 in for Y, 1 for X, those will both end up true. That's the one point they do. Okay, next one, that's number 1, that's number 2. So let's look at 1, and then let's look at 2. Okay, this is in different formation. The X and Y are on the same side. Okay, so what I'm going to do is the 0 for X, 0 for Y. Now, if I would personally recommend putting 1s there. Okay, so 1x minus 1y equals 5, 1x minus 1y equals 5. So if x is 0, that goes away, and then I divide. It's going to be negative 5. If y is 0, that's gone, and then that's just 5. Okay. So 0, negative 5. 1, 2, 3, 4, 5. 5, 0. So 1, 2, 3, 4, 5. So you make it through. You're only going to have 2. When it's in that formation, the best way to go is with 2 points. The x where it crosses the x-axis and the point where it crosses the y. Okay, that cross that out. As soon as I get it graphed, I'm crossing that out. Now let's look at the other one. What kind of formation's that in? That's, again, the X and Y are on the same side. That's called standard formation, so I need to use the 0 for X, 0 for Y. 3x plus 1y equals 3. 3x plus 1y equals 3. X is 0. Y is 0. So if I divide by 1, that's 3. If I divide by 3, that's 1. So 0, 3. 1, 2, 3. 1, 0. So write 1. Okay, do they cross? Sure they do. Okay, right here. Okay, so where am I at for X? I'm at 1, 2, so we're at 2, and then down 1, 2, 3, so negative 3. 2 and negative 3. Okay, next one. Y equals 5x plus 2. That's going to be number 1. That's going to be number 2. I'm not doing this one here. Okay. Okay, so number 1, number 2. Okay, so number 1. There it is. Y equals 5x plus 2. Number 2, y equals 3x. Okay, y is clearly by itself, so slope-intercept form. So I go 0, 1, 2. Okay, and then I plug those numbers in for x. So 5 times 0 plus 2 is 2. 5 times 1 is 5 plus 2 is 7. 5 times 2 is 10 plus 2 is 12. Okay, so 0, 2. I still want you going by 1. So 1, 7. 2, 3, 4, 5, 6, 7. Okay, and then 2 12s off the graph, but that's okay. I can get by with just those 2 points. All I need to make a line is 2 points. That's the definition of a line. It passes through 2 points. Okay, y equals 3 multiplied by x. Okay, y is by itself, so again, it's in slope-intercept form. By the way, m would be 5 and b would be 2, so 5 over 1 and 2, so you go 2, up 5, right 1. But if you're doing this, you don't really have a b, so you'd start at 0, and then you go up 3, right 1, and so forth. Okay, so if I plug in 0, 3 times 0 is 0, you can get 0, 0. 3 times 1 is 3, and 3 times 2 is 6. So 0, 0. 1, 3, so go right 1, up 1, 2, 3. 2, 6, right 2, up 1, 2, 3, 4, 5, 6. Okay, so we graph them. Now, if you look closely, it's kind of a tight fit, but they do cross, and they cross about right there. Okay? So where is that? Well, it looks like we're left 1 unit, so it'd be negative 1. Then we're down 1, 2, 3 units, so that's negative 3. Okay, now I'll set you up with some of these. Okay? You're going to use the 0, 1, 2, if you want to put the 1 there. Okay? And then 0, 1, 2 for both of them. You're going to use 0, 1, 2. And then 0, 1, 2 for both of those. 0, 1, 2, plug them in. Or I think there's a couple of you who do the MB on those, slope y-intercept. That's fine. Okay, here I'll do the 0 for x, 0 for y. I would personally put 1s in front of those if you know that's what you're doing. Okay, 0 for x, 0 for y. Okay, this is in different forms, so it'd be 0 for x, 0 for y. 0 for x, 0 for y. And there should be a point where they cross.